Welcome back. This is Mr. Hassan's Maths channel, and I'm answering a question upon a request of one of the viewers on the channel. A question from an older paper, January 2018, Statistics S1, International A level. This is an Edexcel paper, and here we first of all starting off with something which is kind of IGCSE basic type of stuff. It says shade the region representing the event A union B complement on the Venn diagram below. So A union B complement. So union is like or rather than intersection, which is like and. Union is like the easygoing one. You can think of it like smiley face, whereas intersection is like frowny face, you could say. Right? So this one is kind of like a bit more relaxed. So when you want to do A union B complement, well, if something's mentioned, it's included. So all of A has to be included. So all of A is included. It can't be excluded now because it's union. And B complement is everything outside of B. So everything outside of B is also included. So all of this area outside of B is also included. In fact, you know what I'm going to do? I'm going to shade it in a slightly different way just to illustrate something. Everything outside of B is also included. Okay, so everything outside of B is included. The only thing that's not included is the part of B which is not included with A. Okay, so we have, this is the shading, all of this, including that part, right? Now, the reason why I shaded them different kind of directions is because supposing we just continue this. Let's say we considered this, everything outside of B. Okay, so now basically, if this question was A intersection B complement, we would look to the places which have been shaded in both directions, which would be just that part. But if it's union, we look for any type of shading whatsoever. If it's shaded somehow, somewhere, it's included. So all of this is included apart from this crescent shape. That's the only part that's not included. Okay, so that's how we can understand how that works. So just to make it like more obvious in the end, we know that basically what we have to shade is, so just to make it a bit neater, so what we're going to shade basically all of this area over here, all of the things that are outside of A, outside of B, sorry, but you have to include the part of A, which is inside B. So that would be our region. Okay, so it's basically everything apart from this crescent shape of B. So A means all of A is included, union B complement, everything outside of B is included without, including anything twice. Okay, so there's 2A. Now for 2B, the two events C and D are mutually exclusive. Now, mutually exclusive, that means basically that they cannot occur both at the same time. So, for example, C could be, not with these numbers, but just a general, like you can have two events, for example, P and Q. P could be the odd numbers, all right, all the odd numbers between 1 and 10, for example. And Q could be all the even numbers between 1 and 10. Now, there's no way that you'll have any common ground between them. If you were to draw them, they would have no intersection. They're mutually exclusive. If something's odd, it can't be even. It's mutually exclusive, right? The fact that it's odd means it can't be even because by definition, an odd number is not even and an even number is not odd, right? So therefore, there's no common ground. If it was odd and prime, you can say, okay, yeah, 3, 5, 7, they're prime numbers and they're odd numbers, so there would be some intersection. Okay, so they're not mutually exclusive. So mutually exclusive when they can't occur both at the same time because one of them excludes the other one from happening. Okay, so the two events C and D are mutually exclusive. So that means basically what that helps us to understand is that the probability of the intersection between C and D is equal to 0. There is no intersection between them. Okay, so that's how that helps us. So it says, given that the probability of C is 1/5 and the probability of D is 3/10, find the probability of C union D. So we know that the C union D, if we have our circles, okay, if you have C union D, supposing they weren't mutually exclusive, then what we would have is you'd have the probability of C union D. It would be the probability of C plus the probability of D minus the probability of the intersection between them. Okay, because you don't want to count the same. You want to find what's in C or D, right? You don't want to count this space twice. If you say probability of C plus the probability of D, you've counted this place twice. You take it away from that sum and you end up with the probability of what's in C or D without duplicating this area here, right? If C and D are such that they are mutually exclusive, then what you'll have is you'll have a situation where you'll have C and you'll have D with no intersection, which means this part is going to become 0. So you're left with the probability of C union D is the probability of C plus the probability of D, because there's no intersection, right? So we can say here for B part 1, the probability of C union D is equal to the probability of C plus the probability of D minus the probability of the intersection between them. And we know, because you can write this as your steps as they are. I'm just trying to make my writing a bit neater here. As they are mutually exclusive. Therefore, the probability of C intersection D is equal to 0. So therefore, we can say the probability of C union D is equal to the probability of C plus the probability of D. Okay, which gives us 1/5 plus 3/10. That's going to be 2/10 plus 3/10, which is 5/10, which is a half. So we can say the probability of C union D therefore is equal to a half. C union D is equal to a half. That's part 1. And part 2 says, find the probability of C given D. Okay, now what that means is basically D is our subset. Okay, so when it says given, it means basically you've got to make this our sample space. Okay, so basically what this is, this now becomes our sample space. D is our sample space. And we got to find the probability, okay, of the part of C that's inside. We got to find like the part of C that's inside D. Okay, now if you look at C, there's no part of C that's inside D because they're mutually exclusive. So you can think of this as a formula. This is the probability of the intersection of C and D over the probability of D, which is going to be 0 over the probability of D, which we know is 3/10. Okay, so we end up with 0. Of course, you can see that there's no part of C that's inside D. So if we make D the sample space, there's no part of C that will fit, that will be inside D. Therefore, the probability of that is going to be 0. If they're mutually exclusive, then the probability of one given the other will be, of course, 0, because there's no intersection. There has to be an intersection for this to have an. This is 3/10, isn't it? Doesn't matter, but this doesn't affect our answer, of course. So that's kind of like common sense there, right? So we can say the probability of C given D, of course, is going to be 0. There's no way you can have anything like that because no part of C is inside D, and D is our sample space. Okay, so there's part A done of this question. Now for part B, or part C. That's A and B done. Now for part C. It says the two events F and G are independent. Now here's something which a lot of people mix up with mutually exclusive. Now independent doesn't mean that one can't happen at the same time as the other. It doesn't mean that. All right. It means that, like, if there are two events going to take place, that the first event happening doesn't change the probability of the second event happening. So a classic example of this would be, for example, if you took a bag of different colored balls and you took one out at random, okay, and say there was blue and red balls in there. So you took you took a ball out of there and you didn't replace it. If you didn't replace it, then the second pick, its probability will be affected by what happened on the first pick. All right. So if you didn't replace the ball back in the bag, if you took the ball out and you left it out, and you got less number of balls in there, so that changes the probability of the second pick, and you got less number of that particular color of balls in there, so it changes the probability completely of the second pick. Okay. Whereas if you were to replace the ball back inside the bag and then take the second pick, then the second pick was not affected by the first pick. The probability will still be the same. So an independent, in this case, the second scenario is where they are independent, where the second pick is not affected by what happened in the first pick. You replace the ball back in there, so the probabilities for the second pick will be the same. Okay. So that's when they're independent. And what we can understand from that is that when they're independent, the probability of one times the probability of the other is going to be the same as the probability of their intersection. Okay, that's only if they are that's only for independent events. Okay, and that's the key for us to answer this question. This is only true for independent events, not for, if we don't know it's independent, we cannot use this, little formula. Okay, so first of all, we know the probability of F is 1/6, the probability of F union G is 3/8. Find the probability of G. So we're going to start in the same way as we did before. We can say the probability of F union G is equal to the probability of F plus the probability of G, and as we mentioned, minus the probability of the intersection of F and G. Okay, now what I'm going to do is I'm going to say that I'm going to use the fact that this is the same as this, so I'm going to replace this with the probability of F times the probability of G. So I have the probability of F union G equals the probability of F plus the probability of G minus this. So now I'm going to, just to make it a bit easier, so let X equals the probability of G, which we're trying to find. All right, so probability of F union G we know already is 3/8. That shouldn't be a U like that. Okay, so it's 3/8 equals the probability of F, which we know is 1/6, plus the probability of G, which we called X, minus the probability of F, which is 1/6, times the probability of G, which is X. So now we have an equation in X. X is our probability of G. So we can find this very easily now. We can subtract 1/6 from both sides. And we can subtract 1/6 from 1x. That's going to be 5/6x. Right, so this is going to give you, if you add these two fractions together, you're going to have something over, I think 24 goes into, they both go into 24. 3 times 8 and 3 times 3 is 9, and 6 times 4, so 1 times 4 is 4. So you end up with 5/20, no, 5 over, yeah, so you have 5/24 equals 5/6x. Okay, so the 5s will cancel out if you divide both sides by 5, and if you multiply both sides by 6, okay, to get rid of this, you multiply this by 6, you're left with x equals 6/24, which is 1/4. So therefore we can say the probability of G is equal to 1/4. Okay, so there's the answer to part 1. And for part 2, it says find the probability of F given G complement. Now, there's an easy way of doing this using the formula that we know, that one of the formulae that we should know. It's in the formula sheet as well, and I kind of explained it in the last part of the question, that the probability of A given B is equal to the probability of the intersection between them over the probability of the part that's after the slash, the given. Right, so this is our sample space, and whatever part of this is that's in that is our numerator, and that gives us the probability of A given B. It's called conditional probability. So if we follow the same logic from that, the probability of F given G complement is the probability of F intersection with G complement over the probability of G complement. Now, because they are independent events, if F and G are independent, then F and G dash will also be independent. Okay, so as an independent event, we can say the probability of F given G dash is going to be the probability of F times the probability of G dash over the probability of G dash And what happens? They cancel out. So we're left with the probability of F. Okay, so therefore we can say the probability of F slash G is equal to the probability of F, which was 1/6. And there's the answer. Okay, we can also think of this in another way. Okay, we could draw a Venn diagram. Okay, and we could have the two circles F and G. Right, F and G. And we've worked out what F and G are. So we could work out what the probability of F intersection G is. That's going to be 1/6 times a quarter. Okay, because probability of F is 1/6. That's 1/4. That's 1/24. Which means the probability of F, which is, remember, the probability of F is 1/6. So the part of F which is not in G, which is going to be basically F intersection G complement, is going to be this part over here. Okay, that's going to be 1/6 minus 1/24, which is going to be 4/24 minus 1/24, which is going to be 3/24, which is 1/8. So this part is 1/8. And here you're going to have G is equal to 1/6. Okay, as we said. No, G is equal to, hold on, what am I doing here? G is equal to, oh, we found it already. So it's a quarter. So G is equal to a quarter. So this part here, this whole thing is a quarter. So this part is a quarter minus 1/24. Well, that's going to be like, if you make that into 24 multiplied by 6, that's 6/24 minus 1/24, which is 5/24. And what's left on the outside? Well, they have to add up to 1, all of them, including that part on the outside. So if we take these all over 24, that's 3/24 plus 1/24 plus 5/24. That's going to be 9/24. Okay, so 9/24. Okay, and if you take that, if you do 1 minus 9/24, we're going to have what? That's going to be 9, 10. Okay, that's going to be 15/24. So you have 15/24 on the outside. Because it's 15, 18, 19, 24. Okay, good. So now, this is really a long-winded way. The way that I did it before is way easier. This is the answer. Okay, well, I'm just showing you how it fits in with our understanding. So we want to find the probability of F given G complement. If we do it directly from the Venn diagram, then G complement becomes our sample space. So our sample space becomes all those parts which are outside of the circle, okay, outside of the circle G. So this is our sample space. Our sample space is basically all of this which is outside the circle G. Okay, so the only thing it includes is 1/8 and 15/24. Okay, that's G complement. That's our sample space. Okay, so that's G complement. So that's what we have to divide by, 15/24. Okay, and our, we got to find whatever part of F is in this shape. So actually, our sample space is not just 15/24. It's 15/24 plus 1/8. These two. Okay, that's our sample space. And we're going to find whatever part of F is inside the sample space as our numerator. So it's going to be 1/8. That's how much of F is inside our sample space, divided by the total sample space, which is 15/24 plus 1/24. So you're left with 1/8, okay, divided by, this is 15/24 plus 3/24, which is 18/24. Okay, so that gives you 1/8 times 24/18. So 8 goes into 24 3 times, and 3/18 is 1/6. So we get 1/6. So we say the probability of F given G complement is equal to 1/6. So that's in like an alternative method of answering it, using an understanding of Venn diagrams and what this actually means, from a physical diagram. Of course, this is way easier. You can just use the formula book for that. But that just shows you how we kind of, supposing we didn't know that they were independent, for example. Well, we wouldn't have worked out this anyway. Anyway, so because they're independent, we know that this must be true. Okay, so there's the answer there for this question. Question number 2 from the January 2018 Statistics S1 International A-Level Edexcel paper. Some student requested this a day before their S1 exam in May 2024. So I hope that they understood if they get to watch this. Other questions from this particular paper can be found in the playlist, which is over there. It's pretty full now, this playlist of this question paper. I think nearly all the questions are answered from it. For the older papers, I don't really go through every single question. I go through by request, as I have for this one. Other questions about probability from S1 can be found in this link over here. You can subscribe to my channel if you wish to from the link over there, and the link here takes you to a video which shows you how to use my channel efficiently. Thank you for watching, and see you soon.